These are your notes for Unit 2, Day 6 of Calculus. If you'd like to see the warm-up, the review question, or any homework questions we went over from class today, just look at the finished notes. So today we are going to talk about the chain rule. So we're going to do another rule for derivatives. So we've talked about the power rule, the product rule, the quotient rule. We're going to add the chain rule to the list. So this is when you had a composition of functions or a function that was plugged inside of another function. We use something called the chain rule in order to take its derivative. So the chain rule, again, we use this when you have a composition of functions. So if you have something like f of g of x, we call that a composition of functions. And so if we want to take the derivative of that, you kind of just need to recognize who's the inside function. So in this case, g of x, we would call the inside function. And then the f of x, the f, would be the outside function. And so if you're going to have something like if f of x was x squared and g of x was x plus 3, and we had f of g of x, and you were going to do that, that means you're going to take the g of x, x plus 3, and you're going to plug it into the f of function. So this would be x plus 3 squared. So notice the inside function, we'll make that brown, would be x plus 3. And then the outside function, the f of x, was we were going to square it. So the outside function would be the squared function. So the first thing when you're doing chain rule, you should just kind of look at it and see if you can recognize who would be the inside function and who would be the outside function. So on number 1, y equals x to the third plus 3, the inside function, and we're just going to label this brown. So the inside function is going to be x to the third plus 3, and then the outside function is going to be to the fifth. So when I do this, the inside will be brown, and then the outside will be pink. So when you're going to take the derivative using chain rule, what you do is you take the derivative of the outside function, whatever it is, and you leave the inside function alone. So the inside function is going to stay the inside function. So you're going to do the derivative of the outside, leave the inside alone, and then you multiply it by the derivative of the inside. So in the middle of chain rule will be multiplication. So you take the derivative of the outside function, and then the inside function stays the inside function. So it'll still look like a composition. So you take the derivative of the outside function, the inside function stays by itself, and then you multiply that by the derivative of the inside function. So what do I mean by that? Let's look at an example. So if I have y equals x to the third plus 3, to the fifth power. If I looked at the outside function, how do you take the derivative of something to the fifth power? Well, you would multiply by the exponent and then subtract 1 from the exponent, right? So the derivative of the outside function would be 5 times the inside function to the fourth. So I'm going to leave the inside function alone. So x to the third plus 3. I take the derivative of the outside, so 5 to the fourth. So 5x to the third plus 3 to the fourth power. So all I did was I took the derivative of the outside function. So multiply by the exponent, subtract 1 from the exponent. So that's the derivative of the outside function. I left the inside function alone. So the inside function just said x to the third plus 3. And then I'm going to multiply that by the derivative of the inside function. Well, the derivative of the inside function is 3x squared. And that's it. That's the derivative. So you would do 5 times x to the third plus 3 raised to the fourth power times 3x squared. So you take the derivative of the outside function, leave the inside function alone, then multiply it by the derivative of the inside function. If you wanted to rewrite this, you could say that the derivative is any monomial, so the 5 and the 3x squared are both monomials, so we could multiply those together if we wanted to, and we could write it as 15x squared, and then times x to the third plus 3 raised to the fourth power. You don't have to rewrite it, but if you did, that's how it would look rewritten. So on number 2, the inside function is negative 5x to the third minus 3, and then my outside function is 3. So if I wanted to take the derivative of this, you take the derivative of the outside function. The outside function is to the power of 3, so multiply by the exponent and subtract 1 from the exponent. The inside function stays itself, so negative 5x to the third minus 3, and then you multiply by the derivative of the inside function, so negative 15x squared. So again, my outside function was to the third power, so multiply by the exponent, subtract 1 from the exponent, and then the inside function stays alone, and then you multiply by the derivative of the inside function. And again, if you wanted to rewrite this, this would be negative 45x squared times negative 5x cubed minus 3 to the second power. All right. On the next one, I'm going to rewrite it. This is negative 2x squared plus 1, and a square root is the same thing to the 1/2 power. So my inside function is negative 2x squared plus 1, and my outside function is to the 1/2 power. So using the chain rule, derivative of the outside, leave the inside alone, then multiply by the derivative of the inside. So the derivative of the outside would be 1/2, and then to the negative 1/2 power. Leave the inside alone, so negative 2x squared plus 1 gets left alone. Then times by the derivative of the inside function, negative 2x. So here's the derivative of the outside, and then I left the inside alone, and then here's the derivative of the inside. If I were to multiply this, 1/2 times negative 4x is negative 2x, and then times negative 2x plus 1 to the negative 1/2 power, if I wanted to rewrite it. All right, why don't you guys pause the video and try the one below it? So see if you guys can find the derivative of that using the chain rule. All right, so the inside function is negative x to the 4th minus 3. And then the outside function is to the negative 2nd power. So the derivative, dy over dx, is going to be derivative of the outside, negative 2, and then subtract 1 from the exponent, negative 3. Leave the inside alone, negative x to the 4th minus 3, and then times by the derivative of the inside, so negative 4x to the 3rd power. And again, if you wanted to simplify that, you would get 8x to the 3rd, and then negative x to the 4th minus 3, raised to the negative 3rd power. What if we have product rule with chain rule? So we have something times something else. So we're going to have product rule. And then remember, product rule is you take the derivative of the first times the second plus take the derivative of the second times the first. Okay, so if I were to take the derivative of the first, well, that's just 3x to the 3rd plus 1. So the derivative of the first would be 9x squared. And then product rule says leave the second function alone. So negative 4x squared minus 3 to the 4th. Plus in the middle of product rule. And now we're going to take the derivative of the second. But if I took the derivative of the second, I'm going to have to use chain rule to take the derivative of that. So the derivative of the second would be 4. Leave the inside alone. And then raise to the 3rd power. So negative 4x squared minus 3. And then times by the derivative of the inside. The derivative of the inside is negative 8x. So this is the derivative of the second function. And then we have to multiply it by the first function. Well, the first function was 3x to the 3rd plus 1. So this was the derivative of the first times leave the second alone, then plus this is the derivative of the second times leave the first alone. And I'm just going to leave it like that. What about if we want to do it with quotient rule? So remember, quotient rule said you take the derivative of the top times the bottom, then you minus the derivative of the bottom times the top, all over the bottom squared. So if we're going to do this, the derivative of the top, we're going to have to use chain rule on. So the inside function is x to the 3rd plus 4, and my outside function is to the 5th power. So this is going to be 5 times x to the 3rd plus 4 to the 4th power times 3x squared. So that's going to be the derivative of the top. Then times the bottom, 3x to the 4th minus 2. Then minus the derivative of the bottom is 12x to the 3rd. Then times the top, x to the 3rd plus 4, raised to the 5th power. Then all over the bottom squared, 3x to the 4th minus 2, all squared. And again, I'm just going to leave it like that. What if our inside and outside functions have to deal with trig functions? So who would be the inside and the outside function of tangent of 3x? Well, I could put parentheses around the 3x, and so my outside function now is going to be tangent, and my inside function is going to be 3x. And remember, chain rule is you take the derivative of the outside leave the inside function alone, and then you multiply it by the derivative of the inside function. So my derivative is going to be take the derivative of the outside function. The derivative of tangent is secant squared. Then it says to leave the inside function alone. Well, my inside function is 3x. Then you multiply it by the derivative of the inside. Well, the derivative of my inside is 3. So again, inside function, derivative of the inside function, and then the derivative of the outside function is secant squared. If I rewrote this, I would get 3 times the secant squared of 3x. So I can pull that 3 out to the front so it looks like a coefficient. And that would be my y prime, or my derivative. Okay, on my next one, my outside function is secant x. You can think of it as 4 secant x if you want to. And then my inside function is 5x. So if I were going to take the derivative of 4 secant x, it would be 4 secant tangent. Okay, but I have to leave the inside function alone. The derivative of secant x is secant x tangent x, but the derivative of secant 5x is going to be secant 5x tangent 5x. So both of those insides are going to be 5x and 5x. And then we multiply by the derivative of the inside function. Well, the derivative of 5x is 5. And if I wrote this, I would have 20 secant 5x tangent 5x. So again, you can think of this as 4 times secant 5x. So that 4 can just be pulled to the front, take the derivative, and then after you're done taking the derivative, multiply by 4. All right, on the next one, the inside function is x to the third, and my outside function is cosine x. So chain rule says take the derivative of the outside. The derivative of cosine is negative sine. Then leave the inside function alone, x to the third, then multiply by the derivative of the inside, so 3x squared. And if I rewrote this, I would have negative 3x squared sine x cubed. The next one might be hard to see at first because it's written in the way that's the easiest notation, but I can rewrite it so it might be easier to see so we can take the derivative. This is the same thing as cosine raised to the third power. So cosine cubed x is the same thing as cosine of x cubed. So now the outside function is the 3, and my inside function is cosine x. So if I wanted to take the derivative of cosine cubed x, you would do 3 and 2 for the derivative of the outside, and then leave the inside function alone, so cosine x gets left alone, and then times negative sine x. So if I wanted to rewrite this, I could have negative 3 sine x, and then cosine squared x could look like that. So here's my inside function, derivative of my inside function, and then 3 and 2 are the derivative of my outside function. All right, let's look at the next ones. So we've got some quotient rule. I'm going to rewrite this first. This is x squared minus 3 to the 1/5 power all over negative x minus 5. So I've got an outside function of 1/5 and an inside function of x squared minus 3. So when I take the derivative of this, it's going to be quotient rule. So derivative of the top, 1/5 x squared minus 3 to the negative 4/5, then times the derivative of the inside, 2x. So that's the derivative of the numerator, then times the denominator, negative x minus 5, then minus derivative of the denominator, negative 1, times the numerator, x squared minus 3 to the 1/5, then all over the denominator squared, negative x minus 5 squared. And I'm going to leave it alone. I'm going to leave it like that. On the second one, I've got negative 3x to the third minus 1 times cosecant of 5x to the fourth. Well, my inside function on this one is 5x to the fourth, and my outside function is cosecant. So product rule says take the derivative of the first. So the derivative of my first is negative 9x squared. Leave the second alone, cosecant 5x to the fourth. Then plus for product rule, and then derivative of the second. Well, the derivative of cosecant is negative cosecant cotangent. Then it said to leave the inside alone for chain rule. So my inside was 5x to the fourth. So both of those are going to have a 5x to the fourth. So negative cosecant 5x to the fourth, cotangent 5x to the fourth. Then times the derivative of the inside. The derivative of the inside is 20x to the third. And then times the first function, negative 3x to the third minus 1. So just make sure you have all your parts. So derivative of the first times leave the second alone, plus derivative of the second would be all of this, then times leave the first alone. And we're good with product rule. All right, why don't you guys pause the video and try the next two? So you're going to have to use some chain and quotient. And the second one has a chain within a chain. So see what you guys can do with that. So go ahead and pause the video and try those two. All right, on the first one, we've got quotient rule. So derivative of the top would be 16x to the third, then times, leave the bottom alone, tangent 3x to the fifth, and then minus for quotient rule. My outside function is tangent, and my inside function is 3x to the fifth on the bottom. So the derivative of tangent is secant squared, then leave the inside alone, 3x to the fifth, then times the derivative of the inside, 15x to the fourth, and that would be the derivative of the denominator, then times the numerator for quotient rule, so 4x to the fourth plus 5, and then all over the denominator squared, so tangent 3x to the fifth squared. And I'm going to leave it like that. On the next one, I'm going to rewrite it as the cotangent of negative 5x to the third minus 2, that raised to the 1/3 power. So you've got to be careful. The most outside function is cotangent, but you have another outside function, so I'm going to make that one red. So my second outside function is 1/3, and then the most inside function is negative 5x to the third minus 2. So it's going to be chain within chain. So we're going to take the derivative of the outside. We're going to leave the inside of the inside alone. Then I'm going to take the derivative of the next outside function, and then I'm going to leave its inside alone. And then I'm going to take the derivative of the most inside function. So we've got f, g, and h, if you want to think about it like that way. So f is my most outside function. So if I wanted to find the derivative of cotangent, it's negative cosecant squared. And then we leave the inside alone. So negative 5x to the third minus 2 raised to the 1/3 power. And then, so I took the derivative of the most outside. I left the inside alone. Now I need to take the derivative of this. Well, I've got negative 5x to the third minus 2, and then its outside function is the 1/3. Well, if I want to take the derivative of something to the 1/3 power, it'll be 1/3, leave the inside alone, negative 5x to the third minus 2, and then to the negative 2/3 power. So now I took the derivative of the 1/3 power piece, left the inside alone, and then I take the derivative of the most inside function, negative 15x squared. And that's going to be my answer. All right, gentlemen, your homework is the worksheet for today. If you have any questions, just let me know.